Hello everyone, welcome to the first tutorial. In this tutorial, we'll be learning what electromagnetic induction is and how do we set up experiments to demonstrate electromagnetic induction. So we'll be covering the first learning objective. Let's consider the experimental setup in figure 1. We have a permanent U-shaped magnet, and between the poles of a magnet, a wire is passing. The ends of the wire, they're connected to a sensitive center zerometer. So it is sensitive so that we can detect a small amounts of current, maybe in milliamperes or microamperes, and it is center zero so that we can identify whether there's current in the coil, and we can also identify the direction of the current. So if there's no current, it will be indicating at zero, and if there's current flowing in one direction, it will be deflecting on one side. If the current flows in the opposite direction, it will be deflecting on the other side. Between the poles of a magnet, I'm going to mark 1, 2, 3, 4, 5, and 6. 6 different positions. So when the wire is moved between the 6 different positions, it was only observed that deflection happened when the wire moved between the positions 1 and 2. Because in position 1 and 2, when the wire is literally cutting the magnetic field lines, then only deflection was observed. So what does this mean? It means that the magnetic field lines, they're changing through the conductor, okay? So, or you can say that the conductor is cutting the magnetic field lines only in position 1 and 2. When it moves back and forth, okay, in position 3 and 4, and when it moves sideways, left and right, it is not cutting magnetic field lines, so no induced EMF is produced in the conductor. By induced EMF, I mean potential difference generated across the ends of the conductor so that the current can flow. You know that the current only flows when there is potential difference across the ends of the conductor. So conductor experiences induced potential difference only when the wire cuts the magnetic field lines. In the second experimental setup, we have a coil with 600 turns in it. The terminals of the coil, they are again connected to a sensitive center zerometer. And now we are moving a bar magnet into and out of the coil. Okay, the direction of the movement is also indicated with this blue arrow. So if we move the coil inward, the current flows in one direction. When we move the coil outward, it flows in the opposite direction. So when we're moving the magnetic field, we are changing the magnetic field lines passing through the coil. Okay, when it moves inward completely, there are more magnetic field lines passing through the coil. When we move it outward, fewer magnetic field lines passing through the turns of the coil. So in experiment 1, okay, represented by figure 1, and in experiment 2, the coil and the conductor, they're both experiencing changing magnetic field, and changing magnetic field is the key to generate induced potential difference. If the field is not changing, okay, so let's just assume I keep this magnet inside the coil, okay, the field will be constant, okay, so the number of magnetic field lines passing through the coil would not change. So there's no change in the magnetic field, and there will be no deflection in the sensitive center zerometer. And if I just keep the wire between the poles of the magnet and I do not move it in any of the position marked, so the deflection will not be seen in the meter. So movement is the condition, okay, and the relative movement, okay, you can move the conductor or the magnet itself, but there's one more condition, that the magnetic field lines should be cut by the conductor or the coil. If the conductor or the coil, they're not cutting magnetic field lines, no induced potential difference will be generated. So this is what electromagnetic induction is, and this is how we use experimental setup to demonstrate electromagnetic induction, producing induced potential difference across the ends of the conductor. So I hope you understood the idea of electromagnetic induction and the experimental setup we used. In the next tutorial, we'll be learning about the factors affecting the magnitude of induced EMF or potential difference. So I'll see you in the next tutorial. Thank you.